All right, the first two instructions say to find the circumference. So at the bottom of your formula sheet, you should have written the formulas for circumference. There's two of them. And I see a number one, you're given the radius. So if this is the radius, then you want to use C equals 2 pi r. It's your formula for circumference using a radius. And we know that the radius, r, is 12. So you're going to plug that in for r. So that's going to be a 12. So C equals 2 pi times 12. And then 2 times 12 is 24. So circumference equals 24 pi. But this says round to the nearest hundredths, so that means you do 24 and the pi button on the calculator. And that's going to give you, the circumference is 75 point, I think it was 397, but you're rounding to the nearest hundredth. So that means we're rounding to the 9. So 7 tells the 9 to go up, so it becomes a 10. That's 0, and the 1 goes to the 3. So the circumference equals 75.40. And this is meters. All right, so again, we used the formula with the r in it because we were given a radius. In number 2, you can see that we're given the diameter because the line goes all the way across the circle and passes through the center. So in this one, this is the diameter, is 18. So you could still use the C equals 2 pi r, just you'd have to find the radius, which is dividing the diameter in half. But the circumference also equals pi times the diameter. So the circumference equals pi times 18, or 18 pi, and multiply that, and we get 56, so the circumference is 56.55 inches. All right, so there's our circumference. Circumference is the perimeter of a circle, has its own word, circumference. We're still dealing with circumference.
For software, we're supposed to leave at 10:30, so can I go?
So this says, given the circumference, find the indicated measurement. So again, we're still using the same two formulas. Since in the number 3, I'm looking for the radius, I want to use the one with the r in it. So C equals 2 pi r. But this time I'm solving for r. I'm given that C, the circumference, is 32 pi. So 32 pi equals 2 pi r. Since I want to solve for r, I want r by itself. So that means I need it, that's 2 times pi times r. So to cancel out multiplication, use division. So I need to divide by 2, and I need to divide by pi. And if I do that, then on the right-hand side, the pi's cancel, and the 2's cancel, and all that's left is an r. And of course, when you have an equation, anything you do on the right-hand side, you also have to do on the left-hand side to keep it balanced. So I also have to divide by 2 pi. Again, on the left, pi over pi, that cancels. And 32 divided by 2 is 16. So the radius is 16. In number 4, this time it gives circumference and asks for diameter. So it would be best to use the circumference formula with a d for diameter, pi times d. I'm given that C is 64. So I'm going to plug that in for C, 64. So 64 equals pi times D. I want to get D by itself, so I need to divide by pi. Pi over pi cancels. So D equals 64 over pi. Or if I round that, that's 20.37. All right, so that is circumference using the circumference formula. If you have not already written that at the bottom of your formula sheet, you should definitely do that. The next section is find the measure of an arc or angle indicated. And then it says assume lines which appear to be diameters are diameters. So the instructions about what you're solving for are very important. The word measure tells you you're dealing with degrees. If you had the word length, like 7 and 8, you see length. That is the formula at the bottom of your formula sheet in the middle. That is not in degrees. It's in inches or feet, some sort of linear measurement. But right now for 5 and 6, it says measure, so we're dealing with degrees. So when dealing with angles, angle measures, figuring out which formula to use is based on where the vertex of the angle is. Well, that sort of applies to here. So I'm looking for the measure of arc TVX. So since it starts with T, there's T, then V, so dot by V, then X. So it's the arc that goes around this direction to follow the letters. The arc matches the letters. I want to know what that measure is. I only have 45 and 84 degrees for the central angles. They are central angles because the vertex of those angles is in the center of the circle. And I know that the arc measure equals the central angle measure. So if this angle is 45 degrees, it's a central angle because the vertex is in the middle. Then the part of that arc is also 45 degrees. The next one is 84 degrees. So that arc is 84 degrees because the vertex is in the center of the circle. Okay, so looking forward, I have a set of vertical angles, so whatever that measure is, I know they're the same because of the relationship. But I need more information. I can also see, because the instructions said lines which appear to be diameters are. So I have a straight line that goes through the center of the circle. So that is a diameter. And diameters make semicircles. And semicircles, have an arc measure of 180 degrees. So that means from T to W is a semicircle, so it's 180 degrees. So I can use that to solve for the missing arc right here. So I can do 180, subtract 45, and subtract 84. And it's going to give me 51 degrees. So that tells me the arc TU is 51 degrees. Since the arc measure is equal to the central angle measure, that means this angle is 51 degrees. Vertical angles are congruent, so this angle is 51 degrees. And the central angle is equal to the measure of the arc, so this arc is 51 degrees. And now I have everything I need. If I add up 51 plus 45 plus 84 plus 51, that is all the pieces of the arc. So 51 plus 45 plus 84 plus 51 gives me a total of 231 degrees. And that is equal to the measure of arc TVX. All right, so then on number 6. This time I'm looking for an angle. Find the measure of angle YUZ. So find Y, here's Y, U, Z. All right, so this is the angle that I'm looking for. Right there. I know that the central angle, and I know it's a central angle because the vertex of the angle is in the center of the circle, is equal to the measure of the arc. But for the arc, all I have is 20x. So I know it's 20x, but that kind of helps me, but not exactly all the way. So I need to figure out what else can I do. Well, I see I have this other information over here, the 39x plus 3. And I see 39x plus 3 plus 20x is going to make up another diameter. So that means it's a semicircle. And a semicircle is 180 degrees. So that means if I add those two together, those two pieces together, it's going to equal 180 degrees. So 39x plus 3 plus 20x equals 180. I have some like terms, 39x plus 20x, that's 59x. And then plus 3 equals 180. Subtract 3. So 59x equals 177. Divide it by 59. So x equals 3. But this problem didn't ask for x. It asked for angle YUZ. And I know angle YUZ is 20x. So the measure of angle YUZ equals 20x. And x is 3. So that means the measure of the angle is 60 degrees. All right, so the next section says to find the length of the arc. So this is arc length, not arc measure. Very important you decipher the difference between the two. So arc length has a formula. F L equals 2 pi r times the measure in degrees over 360 degrees. So you need two things to use this. You need to know what the radius is, and you need to know the measure of the arc in degrees. Okay, so I have the bolded part shows that the angle is 240 degrees and it's a central angle. So that means the arc is also 240 degrees, so that is M. M is 240 degrees and the radius is 9. So L equals 2 pi times blank over 360. And I plug in 240 degrees for the measure and 9 for the radius. And you can type it in the calculator just like that. So the arc length rounded to the nearest tenth is 37.7 feet. It's feet because the radius is in feet. And then we're going to do the same thing for number 8. Again, we have L, since we're looking for the arc length, equals 2 pi times the radius, which I'm just going to, the radius, which I'm making a blank, and the measure, over 360. So the measure of the arc that I'm looking for, M, is 150 degrees. Degrees go over the 360 degrees, so degrees go with degrees. And then the radius is 19. So the arc length, type it in, 2, press the pi button, parentheses 19, close the parentheses, a new set of parentheses, 150 divided by 360, close the parentheses, and round to the nearest tenth, so that's one place after the decimal, is 49.7 inches. Alright, so that's the first page. On page 2, we have a different kind of angle. It says solve for x, so we only have to find x. We don't have to plug it back in. This angle, the vertex of the angle, which is point D, is sitting on the circle. So these are inscribed. The inscribed angle is half of the arc, half the measure of the arc, or the measure of the arc is 2 times the angle, however you want to think of it. So this is the second box of your formulas. Again, you know that you're using this formula because the vertex of the angle is on the circle. So here we have that the angle equals 1/2 of the arc measure. Alright, so my angle, in this case, the angle is what's in parentheses. So 8x minus 9 equals 1/2 of the arc measure, and the arc measure is given to me, it's 158 degrees. Alright, so half of 158 is 79. So 8x minus 9 equals 79. Add the 9. And 8x equals 88. Divide it by 8, and x equals 11. So again, you're using this because the vertex of the angle is sitting on the circle. It's not in the middle. It's not in the center of the circle. And the same thing on the next one, number 10. The vertex of the angle is point M, and it's sitting on the circle. So the angle equals half of the arc. And if the angle is 67 degrees, that equals half of the arc, and the arc is this, 4x plus 58. All right, so I can do two different things here. I can either distribute the 1/2 into the parentheses, or I can multiply by 2 to cancel it out. I'm going to go with multiply by 2 to cancel it, but you can do whichever way you prefer. So I'm going to say times 2, then the 1/2 and the 2 cancel, and times 2 over here. Two times 67 is 134. So 134 equals 4x plus 58. And then subtract 58. Which is 76. So 76 equals 4x. And then the last thing is to divide by 4. So 19 equals x. And those just ask for x, so that's it for those. All right, and then the next section is a little tricky because there's not a formula for the next section, the perimeter. The perimeter is just a concept that when you have tangent lines that intersect at a point outside the circle, those segments are equal to each other. So here we have a line, you can see because you have a point of tangency, and you have another tangent line, point of tangency. They intersect at a point outside the circle. So that means the segments that make up the pieces on the outside are equal to each other. And so that, if 12.4 on this piece here, so that's 12.4 over here. And now I can use that 12.4 to calculate this piece. I could say 23.5 minus 12.4. And that's going to give me 11.1. So that means this one is 11.1. And if that's 11.1, the other, its match is also 11.1, which is the other part of the corner. So the two pieces of the corners are equal to each other. And then I can do the same thing over here. If I have 24.1, subtract 11.1, it's going to give me 13. So that means this piece is 13. If that part of the corner is 13, then the other part of the corner is also 13. And all I'm missing is one other piece. So 6.5, so then this part is also 6.5. Now I have numbers for all the way around. So all I need to do is add them up. I like to make it to where I'm adding together 4 numbers, so I know I'm not repeating any numbers. So I know that this side is 23.5. I know this entire side is 24.1. So if I add up these two, that's 18.9. And then I can add up these two, and that's 19.5. And then I add the 4 numbers together, and that gets me the total perimeter. So 18.9, 19.5, 23.5, 24.1. It's just easier to keep track of how many pieces you're adding together and not add the same one twice or miss one. And that gives me 86. So the perimeter is 86. And we're going to do the same thing for number 12. You just have to find a place to start and start working your way around the circle. I'm going to start with this 10.3. That means this side is also 10.3. And then I can do 22.3 minus 10.3 is 12. So that makes 12 and 12. I already have a 10.3 at this top piece. So the one that goes with that is 10.3. And then I already have the 10.5. So the one that goes with it is also 10.5. And now I just need to add them up. So if I add them all up, then I get a total of 86.2. So when you're looking for the perimeter, you have a circle inside of a quadrilateral. The corners, each piece of the corner is congruent. All right, next one is number 13. Find the measure of the arc or angle indicated. All right, so again, I have an angle for number 13. I have an angle, and the angle, you figure out which formula based on where the vertex of the angle is. The vertex of the angle is on the circle, so this is inscribed. When you have an inscribed angle, the angle equals half of the arc measure. So you have to see where this angle is. So there's the angle. So that means the arc for that angle is the entire piece, the entire arc from R to P, RQP. And I have values, 84 degrees and 118. So if I add those two numbers together, it gives me, and then divide it by 2, that gives me the angle. So the angle equals 1/2 of 84 plus 118. So the measure of angle PXR equals 101 degrees. So the placement of the vertex shows you which formula to use. You need to make notes on your formula sheet so that you can figure that out. Again, looking at number 14, here is the angle I'm looking for. The vertex is point Z. So there's the entire angle. All right, and if the angle equals half of its arc, you have to identify where the arc is. All right, so this one's a little different because I don't know the entire arc. I don't know this section over here. But so you have to look at this one a little differently. But if I see it's at 92 degrees, so if I look at the angle for 92 degrees, it has this arc. And so then I can solve for this missing piece, which I'm just going to call it T. All right, so the angle 92 equals 1/2 of T plus 88. I can multiply by 2 to cancel out the half. So 184 equals t plus 88. So subtract 88. That means that 96 equals t. Alright, so now at least I know that this t is 96. But I'm looking for that green question mark. But now I have the rest of the circle. So to get to that missing piece of the circle, I can do 360 degrees for the whole circle, subtract 88, subtract 96, and subtract 100. So that means that the question mark is 76 degrees. And now I can go back to the first part that I set up and say the angle equals half of the arc. And I know that the arc is 88 plus 76. So then the angle is half of 164. So the angle is 82 degrees. Angle RZY.